I have to, work for someone, I would like a place that is more impactful.
Yeah.
The academia, you just do all this work and it ends up in shelves. And you guys just cite yourself.
Yeah, I know what you mean. You just get a publication
That's
number and impact
Well, I've
factor.
seen how many publications you have actually. Was it like 14 or something more?
Yeah, you've got a
Those
lot.
are,
Yeah.
those are the ones I'm showing the harder.
And same with you, Stefan. You've got a few as well.
Not that many, like below 10.
I barely feel like a scientist. 0 publications.
No, don't worry about publication.
Yeah, you get paid.
No, you don't.
He was working as a researcher, but now works with EPA, Environmental Protection Authority. I think he's more fulfilled working with EPA, seeing real problems being solved.
Sometimes university is not the most practical.
Oh, well, anyway, as I was saying, welcome everyone to the hub. We've really rushed to get this together. Within a couple of weeks, we've set up the space and we've put a workshop together, and we've decided to kind of make it a get together for the founders, and obviously Tech, my family, who's here to support. Basically, this space is designed to empower individuals and businesses, to teach them about current technology that we can leverage. We're aiming to be a not-for-profit while we continue to learn about this quickly growing space in AI. So Melbourne AI Hub. Now, a little story about my relationship with AI. I had no idea what AI was until just a few years ago. I'm a biomedical scientist, biomedical grad, and a bioinformatics grad. And as part of that, we did have to do a lot of things with computers. We actually had to code using this program called Ape. And knowing Python was, it was a weak point for me. And after graduating, I spent a little bit of time in the lab, and I went over to NAB. And it was at NAB that I discovered AI. ChatGPT had just been released in 2022 or 2023, and one of the managers there told me about it. And I used it for the first time, and I was shocked. It was like sentient. I asked it a question, and it responded. It said something that I didn't think was possible, and it seemed to respond to inputs that I gave it. So my journey started there. I took workshops and anything else that NAB offered, and I learned a lot. Left NAB and started a little business, cleaning business. And as part of that cleaning business, I leveraged AI to create websites, design some automations, even considered robotics. So I've had one of my cleaning sites get visited by a cleaning robot. So it's an incredible technology, but it's also not a mystery. So that's my relationship. Maybe we'll take a second to go around the room, and Stefan, since you've got the mic, you can tell us what you know about AI, how you use it, and you discovered it.
Okay, yeah. I first started using AI as like an alternative to Google.
Yeah.
It would give me like the more direct answers with context.
Yeah.
And it saves me a lot of time. After that, I started using things like Perplexity for my doing research. It tells you where the sources come from. You can trust it a bit. And then I also, more recently, I've been looking into using different systems of AI, because every AI model has its own advantages and disadvantages. That's why there's so many out there. So my focus right now is really on just understanding as many different AI tools as possible and apply it to the specific situation.
Just learning about this new space that's become
the
available.
more you learn, you realize the more you have to
Yeah, absolutely.
And
Dr. Roby, if you want to just tell us what your relationship with AI is.
I'm still very, very new in this
in this field.
Yeah.
It's just, I would say I was just like most other people that were a bit relaxed, or a bit reluctant to like embrace the AI thing. But recently I've started to like really delve into it. I started with ChatGPT, and I was really amazed at what it could do. I was trying to use it for my business when I have, like things that I don't really understand. How do I really get deep information? So I was using it, and I was really amazed at the rate at which it got to know about my business. Just one prompt, and it tells you real details as to what you can do, who your competitors are, and things like that, and how you can be a bit better than them in terms of adding value to what you do. So that really amazed me, and prompted me to use it more and more. And also the business itself, the energy monitoring business that we are doing, it's also has some elements of AI, because it's about collecting data, ongoing data collection of energy usage. Then for the recommendations and the data analysis first, data plays a significant role. It's not just humans that analyze the data. Just imagine it's huge data. So you need AI to assist you in the data analysis, and that's what they've been doing. So that really gives me, an idea of what AI could do, the benefits of really leveraging AI to find answers to lots of problems. And that's why I'm here, to really get to know more about AI and why we can use it to solve real world problems. So yeah.
Well, I think you've hit some key points there: energy, data, and AI, which all work together. Tech, what's your experience with AI?
Yeah, I just came to learn about AI, but since 2014, I just heard about AI, and
2014?
24,
Oh, 24. Okay.
2024,
Yeah.
I just heard about AI, and then I was using most of the time the ChatGPT, just to get some information, some things that I know. Just ask the ChatGPT, and then I get some information. So I don't have any experience in that AI technology, but today I came just to learn more about it.
I think that is the general population. Basically just uses it. Maybe they think it's magic, but that's what this workshop is kind of designed to do. Shed some light on exactly what it is, how it works. So AI is not something new. It's in fact, it goes back as far as you could say 8,000 years. Written text about AI goes as far back as 3,000 years. So it's not entirely something that's just popped up. But in essence, what it does is there's data. What it analyzes patterns in that data. Then it makes predictions. Then it gives you an output. So it's very left-brained. It's very mathematical, and it works largely through probability. Now, with its history, I'm not sure if you guys know or you've heard of Homer, who was a Greek poet and writer. But in his work that's dated at least to 800 BCE, in the Iliad, chapter 18, he talks about Hephaestus, who was a Greek god for innovation, for blacksmithing, and the Greek god of fire. And Hephaestus had these things called the automata. So this was written in Greek, and what the automata were, inanimate human-like machines, and they behaved much like how modern-day agents, Hermes and OpenCore, kind of like how they behave. So he could instruct them to do something, and they would just do it. So Homer had conceived this about Hephaestus as far back as at least 800 BC, as well as Talos, which was a giant robot, another automata, that was tasked with protecting an island, and it functioned through this lifeblood of the machine called Igor. Now, if we fast track about 2,000 years to the 16th century, in England, there was an English philosopher by the name of Thomas Hobbes, who was born in 1588. He's best known for a work called The Leviathan. He was a known materialist, and he believed that thoughts were physical events, and that they could be understood, and they were governed by rules. And he believed this so much so that he refused to have thoughts in public because he feared that it would be stolen. Now, his work, The Leviathan, what he's known for, it was an ideology that a central authority is required in order for society to function. So he was pro-monarchy, and he said that you needed to have a central authority for everyone to kind of shape up. And so we've gone from Homer's Iliad to Hobbes's actually sitting down and saying, hey, thoughts are physical events. Then go back forward a few centuries, you had Blaise Pascal and Leibniz. Now, Blaise Pascal, he was kind of a prodigy in mathematics. And at the age of 19, he created something called the Pascaline, which was the first physical machine to convert thoughts into actual physical processes. It was the first calculator, and only about 20 of them were ever made. And he made it for his father, who was a tax collector, so he had to do a lot of numbers. And so that was the first known calculator to have been created, and it was the first time that thought could be materialized in a physical device. Leibniz, who came shortly after Pascal, is known to have played a huge role in modern day calculus, and he was the first person to not only do plus or minus with the machine, but through his machine called the step reckoner, you could now do division and multiplication. So we went from machines doing calculations, then people asking whether logic itself was formalized with the step reckoner. After Leibniz came Charles Babbage and Ada Lovelace. Charles Babbage, I don't know if you know Charles Babbage, but he's said to be the godfather of the modern day computer. He was contemporary with Ada Lovelace, and Ada Lovelace is said to be the mother of programming. So we're talking about a time where there's no idea that computers exist, but Babbage put forward the idea that if you had a machine like the Pascaline or the step reckoner, and you could, instead of making it change numbers, you could make it manipulate symbols, then you have a machine that can not only do calculations, but can essentially draw images or create music or write poetry, because at the end of it, it's just manipulation of symbols. Ada Lovelace, her father was Lord Byron, Byron Bay, a bit closer to where you are than us. But Lord Byron is known for his famous quote that truth is stranger than fiction. And it really is, because now that they'd conceived that programming was possible, and they had this hypothetical idea of an analytical engine that you could program and you could make it do things that were associated with being human. They started building a bridge towards modern day AI. Machines manipulating reality, essentially. But that being said, Ada Lovelace, she did argue that machines, they only did what they were told to do. Unlike humans, they could not generate anything new. All they could do was just whatever you put into it. It had a process, which was the programming that she'd conceived of, and the output would be, it would all be predictable. Which the next person, Alan Turing, who played a huge role in World War II. He's known for having cracked the Enigma code, which the Allies and Axis, during the war, he played a critical role. He put forward this question: can machine behavior imitate intelligence? And this question resulted in him creating something called the Turing test. Now, I did have a QR code for the Turing test, but guess it didn't load. But at this stage, everyone's meant to scan a QR code, and I designed a Turing test where it either linked you up with someone else in the room or with a AI agent, and you would have to chat with it for a minute, and you would have to determine whether it was a human in the room that you were talking to or whether it was an AI agent. So that's essentially what he'd conceived of, called the imitation game. Can machines imitate humans? Can it be known that a machine is a machine or a human is a human? But further to that, he also put forward for the first time the idea that you could have a universal machine. So you've got a phone, you've got a laptop. It's not limited to just one task. You can write with it, you can watch videos, you can record your voice. In his time, that was a very abstract idea, that one particular machine could do all these things. So his revolutionary idea was, if you change the programming but had the same machine, you could have it do multiple things, hence the universal machine. And that was really revolutionary at the time. So after Turing, we finally get to AI. So there was a conference called the Dartmouth Conference in 1956, and it was the first time that the term AI was formally coined. It was coined by a guy called John McLaren and Melvin Minsky, and together they worked on very revolutionary aspects that are still current today, like time sharing. So cloud computing uses time sharing. It was conceived in the 1950s. They also put together Lisp, which was a way to use symbols to manipulate algorithms, so that you could end up with something that was, seemed sentient. Or they also came very close to cracking the Turing test. The idea that artificial intelligence would become what it is today was essentially conceived of in 1956. Now, Melvin Minsky, sorry. Melvin Minsky, he was the first person to put snares or neural networks together using vacuum tubes. So neural networks with deep learning that we've been talking about, they weren't really a thing. There was, should probably use my notes. So John McCarthy was his name, not McLaren. So together with Melvin Minsky, they also founded the AI Hub at MIT, and the Snark machine, which was the first randomly wired neural network made of vacuum tubes. It could teach itself and replicate human neural functions. So he also conceived of the Minsky machine, which was a theoretical model for computation. After them was Geoffrey Hinton, who is known as the godfather of modern AI. So he's responsible for deep learning. He did amazing works in the field of neural networks, especially computer vision, and AI as we know it. But just a few years ago, Geoffrey Hinton left the company where he did all these works, Google, and now he's going around warning everyone about AI. So here's a short video about Geoffrey Hinton.
Your Majesties, Your Royal Highnesses, Excellencies, dear laureates, ladies and gentlemen. This year, the Nobel Committees in Physics and Chemistry have recognized the dramatic progress being made in a new form of artificial intelligence that uses artificial neural networks to learn how to solve difficult computational problems. This new form of AI excels at modeling human intuition rather than human reasoning, and it will enable us to create highly intelligent and knowledgeable assistants who will increase productivity in almost all industries. If the benefits of the increased productivity can be shared equally, it will be a wonderful advance for all humanity. Unfortunately, the rapid progress in AI comes with many short-term risks. It has already created divisive echo chambers by offering people content that makes them indignant. It is already being used by authoritarian governments for massive surveillance and by cybercriminals for phishing attacks. In the near future, AI may be used to create terrible new viruses and horrendous lethal weapons that decide by themselves who to kill or maim. All of these short-term risks require urgent and forceful attention from governments and international organizations. There is also a longer-term existential threat that will arise when we create digital beings that are more intelligent than ourselves. We have no idea whether we can stay in control, but we now have evidence that if they are created by companies motivated by short-term profits, our safety will not be the top priority. We urgently need research on how to prevent these new beings from wanting to take control. They are no longer science fiction. Thank you.
So that's the godfather of AI. And he left Google 3 years ago, oddly the same time I discovered AI. And now he's very cautious about the guardrails that AI has, which the seriousness of it really, you can't really grasp it unless you're actively using the cutting edge AI capabilities that are present to you right now, such as agents. You'd see that agents almost seem alive. It's fair to say that they would pass the Turing test where they are right now. So why does this matter? Sorry. That's your handover, Stefan. It's coming. Well, essentially, there's massive amounts of data available to us right now. Interfaces are relatively cheap. Cloud computing, also cheap. Language models, so language is no longer a barrier. Vision, anything that we can see, they can see. And AI agents, which, like I said, give you the impression that they're literally alive and sentient. So AI is moving from like an interesting tool, as you described it, Olu, something that you just use for Google searches, to actual working infrastructure. So I'm sure that Dextron or Best Energy, they utilize it to manipulate data, but that's probably a limited use of what it can do now. And maybe expanding on that would be thinking forward would be the logical step. Like I said, energy is a big aspect. We're on batteries right now. We've gone through 18% just giving this presentation. That charges because we're using fossil fuels to power up the grid. So this is important, and it's something that people should start considering. Now I'm going to hand it over to Stefan, who is a fan of AI, I guess.
Yeah, just a fan.
He uses a tool called Base 44, which I have limited exposure to. And he's going to show that we've moved from ancient symbolic machines to actual AI that create things.
Okay, I need to connect it to my internet.
HDMI cable, or do you use
HDMI is good.
HDMI?
Yeah.
Good. All right. You ready? Olu, it's for you.
Thanks.
Okay. Okay, hi everyone. I'll just talk about my my short journey in AI. I'm sure Ted's been in the journey much longer than me. I only started my journey a few months ago, basically. So, and during this short time, I've learned so much. I'm not sure why it's flickering that much. Is there a compatibility issue?
Flickering?
Yeah.
Maybe your graphics card is too hardcore for it.
No, it's just a gaming laptop.
Interesting. Yeah, I was telling all who usually send it to each other.
Mm.
Is it like flickering through two different views?
Yeah, not
Yeah.
sure what it's doing.
Maybe that's a setting that you've got on. Go to the display settings. It doesn't look random.
Mhm.
It's like
Yeah. I can't control my screen because of this now.
You're just going to use AI to solve a problem?
Yeah, this is a good demonstration.
Yeah. Cable, the refresh rate is matched between laptop and
Okay.
quality HDMI cable. Do you have another HDMI cable?
It's flickering between duplicate the displays and extend these cables. It's so funny. I think it's a glitch, see?
Yeah.
No, I think it's hesitating between the two. That's why it's I haven't seen this happen before. Let's say show only on one and see what happens. So, hey, is that stable? Keep changing. I think that might have done the job. Oh, now it's okay. Now it's fine. Now it's on extended display, but let's keep it at that. Okay.
So,
it's a bit hard to control, but okay. Yeah. I might just go this way. So. Okay, so we'll wait for Ollie to come back. It's a good beginner tool, but by no means it's as you go. It's not that you'll find its limitations, which I'm starting to find. It's not good for production grade material. It's good for like prototyping ideas and things.
I heard Apple's tracking. So, from what I understand, you can publish to the Apple Store,
Google
or to
Store.
the Android Store.
Yeah,
base
you can. Yeah.
I'm assuming they charge you a premium to be able to do that, to build the apps that you publish.
Yep.
But Apple's cracking down on base 44 built apps.
Yeah. So I don't intend to like build to publish, but I just use it to make tools for to help in my work.
My hope is by the end of tomorrow, you never use base 44 again. That's my hope. But again, I don't know much about it. So.
Yeah. Okay, I'll just start. So base 44 has helped me a lot in my beginner's journey to AI. It makes it not so complicated because it's got a simple interface. It's got the full stack built in, so you don't have to build in your own online database like Superbase. It does all the integrations automatically. Okay, so here I'll just do a quick demonstration. You can say something like build an app for taking meeting notes. And you can put it in plan mode to give it more context. So if I put it on plan and then run this, it will do some thinking. So this will guide you about what steps you should take for your app. Should we close that door? And okay, it's come back with its first question.
Asks you follow-up questions.
Yeah, to sort of lead you into the right direction and gather more information about what you want it to build. So asking who is this app for and how is it used? Is it for just me, a small team, a multiple team, company-wide, or something else? So for this instance, I'll pick small team. Next. What's the core thing you need the app to do? You can say, you can tick multiple things and say even something else. No, actually, no, I'll just tick all these at the moment. What style fits best so you can give it the look that you want? So we can say structured and professional and send. Okay, and then it's got that information. Now it's doing some more thinking. 2 more quick questions. How are meetings organized? By project or team? Chronological only by person? We can say by project or team. Next. For action items, how important is assignment and tracking? Let's just say, let's just pick the middle one. Okay, now it's doing a bit more thinking.
So it doesn't just create the app, it asks you follow-up questions.
Yeah.
Have you always done this? Is this a new feature that they're putting in?
No, this is an existing feature since I first started using
Has
it.
it developed since you first started using it?
It feels faster now.
Yeah.
It used to be a bit more slow.
Okay.
So I think the speed of it's increased. Maybe it's using better models out there. So now we can start building this with this demonstration. And it's building that idea. So while we're doing that, I can just show some of the builds that we have.
So will that work in the background? Say you lose internet connection.
Yeah,
Yeah.
it will still run because it's processing in the cloud.
Okay.
Before I've exited and come back, it's actually it's not processing on a computer. It's processing on a supercomputer somewhere. So you can see all the apps over there. I can see Olu's out there. The what trace one. So I can show you one of the apps. Like this app is the first one I've built on Base 44. Me and my business partner in Brisbane, we do building management. So we just use these, like this app, to just track what we need to do at work. So we've got like a few different complexes and sites. I made one. We don't really need that anymore. I think Ted's got a better one. But like say for this is there's like a
the preview of one of the apps you've made?
yeah. I'm not sure what it is. I think it's just not stable. Maybe it's processing some other stuff. But I can just copy this. This is the published link, so it should be a bit more stable. So you can see it's got a URL. You can actually, if you've got your own domain, custom domain, you can use that. So you get rid of that base 44 thing.
I was not able to do that.
You
You're
aren't
going
able
to show me how to do that.
Okay.
You know, when I posted it on LinkedIn, LinkedIn was actually warning people that it could be malicious.
I think base 44 may have
Malicious,
gotten a bad reputation a bit. Maybe people use it to generate scam apps, that sort of thing. So, okay.
Just like Jeffrey Hinton said, right? There are malicious actors. We need to be careful.
Yeah.
About, we need to ensure that this technology is used to benefit others.
Was a very, very,
Unfortunately,
strong point.
Yeah, unfortunately, people do use these to generate malicious content. So, here you can see, I can go to my dashboard here. I use it to manage tasks at work. So you can see like these are all maintenance sort of tasks. I group them in priority. You can add new tasks and assign it to people, and then put notes. I can even have it linked to my Google Drive for some documents. And here you can see like the tasks that are completed. At work, we need to generate some reports sometimes, and I made this like feature so I can generate that in real time. And this is
generate a report that it generates.
Yeah, and then it's really useful for all I need to do is just like print as a PDF, and I can just send that into email.
So you can't export it. Can you add that into the tool?
I could, but at the moment, because I'm probably the only one using it, it's just easy for me just to press save print as.
Yeah.
I found what base 44 isn't that good at, and based on the reviews that I've read, it's good at creating things quickly, but it's not that good at debugging issues. Like people have to prompt it so many times to fix issues.
Yeah.
And that really drains the credits. And
credits.
Yeah.
So do you get? Is it generous with what did this app cost you to make?
This app probably cost me, let's say, about $50 US.
This app cost you $50 US?
Yeah, to make this. Yeah.
How much time? How
Mainly
many
because of
prompts,
the debugging. I'd say probably like more than 100 prompts just to, because some of the issues I had to fix, I had to go back into the back end to fix, like like it couldn't fix it. It still couldn't fix it by itself. So I actually had to investigate, go into the.
It's just a web app. It's, you can't see this on the Apple Store or.
No, I haven't published it because it's just for internal use.
Would publishing be additional costs?
Yeah, there will be a cost of that you have to pay to Google or Apple to put on the App Store.
Okay.
So, and because this isn't that refined, it's
Yeah.
not
Because that just
Yeah.
from experience, publishing an app is quite difficult.
It
No matter
is,
what
it
tool
is.
you use, right?
Yeah.
But if Base 44 is good at doing that, maybe it's worth it. So have you published any apps?
No.
Android or?
No. Okay, so I think that's that there. I'll show you another. Let's see what's it done. Okay, it's actually already finished.
This is your meeting notes?
Yeah, the one that we just prompted. So it's already come back quite quickly, just 4 minutes ago actually. So that was pretty quick. That, by the way, would have taken an IT person. How long do you reckon that would take?
3 weeks?
Yeah, a few weeks of work done in a few minutes, basically. So here, let's test out this app. So you can say this project name, okay, product launch. It's an optional creator. So you can see it's already there.
So if you want to add voice or camera, does it give you the capability to use the device?
It can. It comes with this integrations, and the integration credits are quite a lot.
Integration credit.
Yeah.
So what is integration credit?
Integration credits is whenever you make an API call. So when you call it to something like Google Drive, you call it something to Monday.com, Outlook, or you call it to like a large LLM. So if you call it to like ChatGPT or something, that would consume integration credits. The other credit type up here is the message credits, which is the one that drains quickly. It's the one that we use to prompt it, like to build the app. Like each instruction will cost a certain number of message credits. It's interesting because like the more complicated or the shorter the message, it takes up the same number of message credits. But what I realized is in the beginning, I would try to have the prompt written as a whole paragraph to save credits.
Yeah.
It builds a lot of things with that big prompt. But what's the downside of that is you can't really assign a priority for the importance of things. Maybe you can, but it will sort of get distracted and then lose focus on the main thing you want it to do, and it tends to introduce bugs because if you're doing step-by-step prompting, that's more logical, and then you can sort of backtrack a bit, go backwards to find out what went wrong.
Yeah,
is that what you realized as well?
The pollution IQ. I'm not sure. I didn't see that. The one I did, I actually used a very large prompt.
Yeah.
And it was able to like do a lot. Then subsequently, I started adding some other prompts to improve it. That was the approach I used.
Yeah. Actually, what I really want to show you, like probably the most advanced app I have in Base 44 will be the
Seems it's not there.
Oh yeah, Synergy Lab. So as you're talking about the integration, so here I put the AI integration right into the app itself. So what you have here is this is a team synergy app where you have all the members and the people involved in projects with their skill sets. And once that's inside, like say this is Olu's friend, it's got all the information about what he does, his experience, his areas of expertise. we put that into the database. The computer, I mean the AI itself can use that as context to create ideas, and you can say something like quick projects for recycling, and then you can analyze that context. So the context here will be recycling, quick projects, and the skill set of all the people.
But does this charge you your credits?
No, this doesn't. Oh, this charges the integration credits. So here, not the message credits. It uses up the integration credits.
It seems like you don't use that.
Yeah, integration credits probably designed for like for production. That's if there's more people using the app, that's where it'll start draining faster. So that's why message credits always drains faster, because message credits, it's the one that get used up here. If I tweak the app, if I say turn turn that from blue to red, that will charge me, I think, like 1 credit or something. So they use up quite quickly.
Are there loopholes?
If you're going, there is, like discussion mode costs less, I think 0.3 credits. So that's why, I'm not sure if Ollie, if you tried using discussion, you can use that to save
I use it
credits,
sometimes, yeah.
to give it more context
Yeah,
and then build it.
before.
Once you're happy with the discussion. I think it's come back now. So okay, so it's got these projects in mind. So AI-powered waste segregation stream, bioinformatics for, I think that's good for you, Teddy, for recycling additives. So we can like save that idea, and it will save, and I can go to saved ideas.
Build on it.
Exactly, yeah. So here, I can say that's a 5-star project. I like it. I can expand on it. So this will probably use like a higher model to give it some more detail.
Okay. So you prompted all this in?
Yeah,
Every single detail? Yeah.
You can see my prompting history from here. So this is like a...
You scroll up all the way to the top?
Yeah.
Okay. About 50 prompts or more?
More, yeah.
Two-way GitHub sync. So you've synced it to GitHub. You can...
Yep, there it is. It's got a repository there.
So all your code is there?
Yep.
So that gives you the option of exporting it?
Yep. So here, you can see how it's expanded on the project. It's given a detailed research plan, methodology, challenges, success metrics, etc. That's coming from, okay, I can actually show you. I can make this a project now. So we go to the projects page. You can see there's a few here. Oh, I've put in all these ones out here. The tree vascular project. So say here, if we look in the details, here you can see the model being used as Gemini Pro. I can reanalyze it with a different model. I find it's good to cross-check with different AI models, different LLMs. Like all you have to do is just copy and paste this text into a different model. So say I'll go here. Because it's always important to cross-check and research. So like say, you can go to like Perplexity.
You use Perplexity as well?
Yep.
Okay. Any experience with the Perplexity computer?
No, I haven't. No, I haven't used, because you have to pay for it. It doesn't come on the free tier.
Yep.
So we can say we can. Oh. Okay, it's already guessing that I want to review it. So it says that came back. Did you see how quickly that came back? I just pressed enter and it's instant. It's just so scary. All these AI models are just getting faster and faster, I realize. Yesterday, I for work, there's a few maintenance quotes that I wanted to analyze. I just uploaded a few PDFs in, and it came back in like 2 seconds. It's like a really long email about proposals to the body corporate. So it is actually quite scary. So it says here, your strategy is already well structured and fundable. The main gap is not concepts, but differentiation, defensibility, and execution risk reduction. And then it's given like a tighter research grade expansion that strengthens the novelty to attract funding and anticipates the reviewer scrutiny. So that's good. In research projects, you probably want to get more scrutiny at the early stage. And I think here,
Do you know what model this is using? The very bottom I see model. Maybe.
it could be an auto. Yeah. Yeah, in the free tier, it doesn't come with too much. Actually, I want to show you guys another app right now. This is one here. Oh no, not this one. Oh yeah, this one. So here, I've made this one here. You can learn about different AI tools. So you can see in each category you've got so many. So let's say for work productivity.
Oh, this is the app for finding AI tools.
Yep.
I tried to use this. The filter is an issue that I had.
Excuse me, please.
This one.
Oh yeah, I haven't published this one yet. The old version, yeah.
Oh, okay, you've updated it.
Yeah, but it's still. I haven't published it. I haven't sent you guys the link. It's still in progress. I'm not really sure too how useful it is anyway, because like you can probably. It's good. You think it's good? Okay.
Because there's so many tools.
Yeah.
If you use the right tool, right?
Mm.
Like if you don't have a hammer,
Mm.
can't put it nail.
Yeah.
Just like that. You have to have the right tool.
What I find now, like back in the 90s or 2000s, you just have to know Microsoft Word, Excel, PowerPoint, maybe a PDF editor. But now you're just like, we're getting to the stage where you need to know more. Like you can't just be like good at a few different pieces of software. If you want to really specialize, you probably want to probably know like 10, 20, or maybe even more, depending on what you're doing. Like really tailored AI-powered tools, applications for what you're doing.
If you scroll all the way to the top,
yep.
Trying to see. Go down.
Yep.
No filters. It's categories. Oh, I see. You choose what category.
Yeah, I haven't updated the. But there's also like the admin section.
All those made it very clear that pricing.
Hello. Good
Here you can add tools and things like I would have like a news section as well, so like it updates you about what's new in the AI market, like what people have made. I think that would be. Yeah, I haven't gotten around to configuring it that well. Like it's still giving me news that's like about a month outdated. Like, the news API, but
So you can ask agents. Complexity is good, right? Complexity is the only.
I think you're calling the wrong number. Who do you want to talk to?
Yeah.
If you had a complexity AI.
No.
API.
Yeah. I know Grok is also very good at that. Grok with a K. There's two Groks. Grok with a Q is the lightning fast one.
Probably linked to XAI.
Yeah, the one with the K is the one links to.
Okay,
yeah.
thanks.
Can you search something in this app? Because I did see the filter come through.
Yep. Let's go back.
It only appears when you search.
Okay. So what do you want me to search?
News, up-to-date news or something like the news.
I'm not sure if that one's like AI powered or it's just internal. I think it's probably. Oh yeah, these tools designed for pulling up to date. Yeah. So it's got two different here. U.com. I've heard of that before.
Now, can you filter through these?
No, I don't have a
You
filter.
don't have a filter.
Yeah. So you do like this idea?
Yeah, so it's critical. There's one other person who's like a promoter for AI, and his whole product is just displaying all the tools that are available. Obviously, he's got a refined search system. Prompting to look through tools is good, but why I keep bringing up filters?
For things like orchestration, this is more important. You can see how many orchestration tools there are. This is like the plumbing of AI.
Yeah.
There's just so many out there, and you don't know which one's the best. Oh, this is the one you talked to for NAN.
You finally found NAN.
And there you go. It's got the link there.
Got a video there.
Yeah. Okay, I think my time's up. But this is basically what I've done in Base 44 with my for beginner's journey in AI.
Yeah.
Yep. Okay, I'll hand over to Olu. Thanks, everyone. Thanks. Yep. I'll let you take it off. Let's see.
You bring all the stuff to repair the fish tank? No. Go shopping today.
I didn't want to bring the chemical.
Like a terrorist.
All right. Good to be here. And I just want to give a brief presentation on energy optimization. Actually, what I did was look at many sectors, manufacturing, hospitality, and many other sectors. And the focus was actually within Melbourne, looking at their energy usage and the possible energy waste within the system, and also looking at what that means, for their emissions, greenhouse gas emissions, because a major source of emission, is your energy use. So if you're able to deal with your energy usage, if you're able to optimize your energy usage, what you are simply doing is you are reducing your emissions. So it has both environmental and economic implications. So focusing on manufacturing, you'll be surprised to know that manufacturing companies, they actually waste as much as 30 to 200 gigawatt hour of electricity per year. That's up to 30% waste in the system. That's huge. That's a lot of money going down the drain. And that's also equivalent to 21,000 to 140,000 tons of CO2 equivalent per year. That's also very, very huge. So, but what's surprising about this is that this waste is insidious. You don't even know it's there. It's not visible. And people are not really making much efforts to seal the leak. But the truth is, organizations might be wasting millions of dollars every year, and there is need to do something about it. So we want to look at, the organizations now specifically, looking at them individually. For steel, because of various processes like smelting, heat treatment, and so many other operations, the loss in the system
200
The-
gigawatts.
Yeah, this is talking about how intensive. It's not the waste yet. It's how intensive in terms of what they consume. This is talking about the consumption.
Is that per
So
plant or is that globally? Per
Yeah.
annum?
Yeah, that's per year, per annum.
For the whole
consumption.
industry, or is that just one plant?
Like for a plant, average
Just a plant.
consumption.
Wow. Okay.
For
Yes.
glass and recycling, 50 gigawatts hour per year. For food processing, and those are the various processes, refrigeration, pasteurization for food processing, batch processes in breweries and chemicals, and so many other things that they do. So they are really, really energy intensive, in their manufacturing processes. And now talking about the energy waste, what does it cost a manufacturing plant? In terms of the waste in the system, it could be as much as 10 to 30% of how much they are spending. Just imagine you are spending $100,000, say $100,000, and you could be wasting as much as $30,000. That's what we are saying, 10 to 30%. And in terms of the lost energy, 3 to 60 gigawatt hour per year. And in terms of the dollar value, millions of dollars every year, for those various pressures that we have mentioned. It's not just an environmental issue, it's a profitability issue, and it's very, very important that organizations do something about it. And that's what we are doing, and that's what the Hub is also thinking of doing, like educating people to get to know about this insidious waste in the system, and the need for them to create visibility and do something about it. Because if you are talking about sustainability, whether it is economic or it's environmental, the starting point has to do with dealing with your energy wastage. I don't have a slide. I was going to put it, but I forgot. There was this slide that shows the contribution of different areas to emissions, greenhouse gas emissions, and electricity. Energy actually played very, very significant role. As much as, if I remember, more than 50%. For various organizations. So if an organization can really deal with their energy waste, then apart from helping them save costs, they're also doing a lot regarding the environment. So now we talk about the emissions. We've talked about the effects on the pockets, on the bottom line. Now, looking at the emissions, for example, for the steel, for steel production, the greenhouse gas emissions could be as much as 100,000 tons of CO2 equivalent per year, on the average. And let me break down scope 1, scope 2, and scope 3 emissions. Scope 1 emissions are emissions within the confines of the organization. For example, maybe you produce your energy and from fossil fuel, whatever emissions that you have within the confines, that is within your boundary, whether it's operational boundary or the geographical boundary. Operational boundary in the sense that, you might be controlling some other companies that are not within that confines, Maybe you're like the parent company and there are other companies that you are controlling, Whatever comes from those companies and your company, those are scope 1 emissions, direct emissions. Any emission that is that has to do with your electricity, gas usage, and some other usage that has to do with energy, those ones are your scope 2 emissions. and emissions that are related to supply chains, is the scope 3 emission. So when you, like I said previously, when you tackle your energy usage, you are indirectly reducing your scope 2 emissions, most likely. And that is, a major common source of emission for most organizations. So when you deal with it, you are helping solve a lot of problems.
Olu, just back on that slide, in scope 1, you see still it says 100,000 tons of CO2. What is the E after the CO2?
The equivalent.
That means equivalent?
It's like a way of standardizing, the emissions. So they call it CO2 equivalent.
And for scope 3, are we just talking logistics, for trucks traveling?
Yeah, different, like, for example, if you've subcontracted your, say, transportation to another company, that is handling that, whatever emissions that come from their, operations is scope 3. Whatever is not directly from you, that is from elsewhere. Maybe your staff is traveling abroad and he flies to the US, for example. Whatever emissions is scope 3 emissions. So scope 3 emissions are very, very difficult to estimate. That's why it's a very, 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 big issue. The Australian government just came out with a policy. I think I mentioned it. They call it ASRS S2, Australian Sustainability Reporting Standard, which requires large emitters, to make disclosures of their of things like this: scope 1, scope 2, scope 3 emissions, and how all these climate events, all these bushfires and everything, how they are affecting them. They are supposed to show this in their financial reporting, something like that. It's making it compulsory for organizations to do that. It started last financial year. You have 3 groups. What?
Is there like a trigger for do they need to reach a certain amount?
Yeah. It depends on your staff, your revenue, and some other things.
So it's based on revenue.
Revenue is also part of it. So they have grouped organizations into 3: group 1, group 2, group 3. Group 1 started last year, the very big organizations. The new groups will be starting this year, and the group 3 will be starting next year. So they have to do all this. Apart from the fact that they have to, give all these reports, because of the scope 3 supply chain parts that requires them to get information from even other organizations they are dealing with. Even smaller organizations that don't have to make these disclosures will also have to do something about scope 3 emissions. So it's something that most people will have to do now, and it's all about getting to know how this thing affects you and getting to know what efforts you are making, to mitigate the effects.
The scope 3 includes your materials. Say if you use batteries for your work, do you have to consider the environmental impact of making batteries?
Yeah, it might be, but mostly it has to do with supply chain. Supply chain, you may be directly involved in your operations. You get it? Directly involved in your operations.
Fossil fuels are involved when you say supply chain. That's all I'm thinking. Fossil fuels.
Supply chains, for example, you are buying something from someone.
Yeah.
You are selling something from someone. You are not an isolated business. The value chain. If, for example, you are adding value to your product, you have to consider the emissions. And that's why every organization needs to have these records, so that if someone needs it and gets in touch with you, you'll be able to supply that information.
Yeah, well, it seems like it's just doing business well, right? Just keeping track of all your data, really.
And there are some guys that are already into this, because because it's a new policy. So even to get this done, most organizations don't know how to do it. They don't, they're just starting out.
So do
estimate.
Yeah,
Just
so
based on like your accounting document.
but you need to like maybe have like more advanced way of doing it, and that's where AI comes in.
Right.
Make assumptions.
Yeah, exactly. That's what they do. They just say, okay, we bought so amount of fuel. It's never correct, but you have to like.
So in these bigger industries like steel manufacturing or food processing, we're talking gigawatts. Small percentage or 1% or 2%, if you're off, you're talking like lots and lots of energy, right?
Yeah.
But if you look at because I'm assuming this policy affects every business, or
no, for now I don't think it's every business. It's those big emitters, those big, very big organizations.
Specific to manufacturers.
Of course, hospitalities and some other sectors will be part of it, not just manufacturers.
Okay.
Yeah.
But if you look at all small businesses, a collective, all the small cleaning businesses, for example, if you look at it as a collective, a small percentage change in their like the way they do things would still have a huge impact collectively, right?
You're right. Right. And that's where the supply chain comes in. That's why I'm telling you that even if they are not reporting directly, the bigger emitters, when they have to do their computation, we still have to get in touch with the smaller ones to be able to track what is happening within that chain.
Oh yeah, because if you're cleaner to like a big company,
they might need to ask you and ask questions, and you need to supply the information.
Right.
So, for I don't want to bug too much about this. What's driving the energy waste? Thermal inefficiencies, under optimized machinery. So those are some of the issues that are causing the waste in the system, and they need to really address them to solve the problem. So why hasn't this been fixed? The problem. So that's where we're gradually going into AI now. The problem is there because there is no real-time intelligence, to track energy use. So if you don't track it, how would you know if there is waste? If you don't track it, how would you, change management? How would you do new things to reduce your waste and to reduce emissions? So so that's the reason why the waste is still persisting, because it is invisible. So we need to make it visible. It's not something you just do like you're doing energy auditing in 1 year. Some people don't even do it at all. You are in maintenance, People don't even care what is happening, So you install solar panel. It's not bad installing solar panel, but what we believe is that the starting point is know what you are consuming, do the monitoring. If there is need for you to reduce the waste, if there is waste in the system, reduce the waste. When you have reduced the waste, you can then install your solar panel. In that way, you will not even spend as much money, because you have already reduced waste, and then when you install your solar panel, it's exactly what you need in terms of the capacity that you install. You will not just go and install something this big when what you actually need is this. You get it? So so that's the starting point, really knowing what is there. And there is even this belief that energy efficiency, even if you can just be efficient in what we have, we will solve a lot of problems. All the environmental problems that we're having, most of the environmental problems we are having, we are more efficient. We'll have been able to solve them. So the starting point is being efficient before we then move to renewables. It's not about just continue to do things as usual and just switching over to renewables. That will not solve our problem. And if we are not careful, all these 2035, 2050 targets that we are pursuing might be just mirage, might not happen. That's the truth.
So with where it says audits are periodic, for example.
Yeah.
Or the data exists where it's actionable. What's being done about that? Or what can be done about the two particular issues?
It's still the same thing I'm talking about. Like our submetering device, for example, that we're planning to install in the hub. what it does is, instead of just periodic audits that you do, when you have those submetering devices, you do real-time, data collection, real-time monitoring, and what makes our own system even unique is the fact that it's at asset level. So you'll be able to know in real time what each asset you have within your organization, for example, manufacturing sector or company, what each of those assets is consuming per time. So if there's any issue, if there's any waste, you'll be able to identify and you'll be able to do something about it to reduce the waste, per time. So instead of doing it like the traditional way that is just periodic, you just leave it there, everything is invisible, you don't know what is happening within your system in terms of energy. When you do real-time monitoring, you'll be able to know what is happening per time, and you'll be able to, take action, very early. So yeah, so that's it. Those are the things. The complexity to across lines for many organizations, they will not be able to monitor that complexity. But when you have something like our monitoring device checking out things, you know what is happening. It creates visibility. You cannot manage what you don't measure. You can't manage what you don't measure. What most people are doing is they are trying to manage something they don't even know anything about. That's what's happening.
Okay.
So it's just the same way that we're talking about, just what I said initially. So it's about changing the traditional view, to something more useful, thinking at things from looking at things from a different perspective. Instead of looking at energy as a fixed overhead, you see it as a raw material input that can be optimized. Instead of just thinking that the only way of dealing with things, which is traditional view, is just to switch off things if you don't want to use too much energy. It's about optimizing consumption, and that's what we are doing when we are monitoring at asset level. We want to optimize consumption so that it doesn't use too much, it doesn't use too less. You have the best of it, and you can avoid waste, and with economic and environmental values. And of course, cost is also a very important thing. Most people don't know that they can reduce cost from other sources apart from procurement. If you manage your energy use appropriately, optimally, you'll be able to cut costs. And of course, we also need to change that perspective. Most people think that sustainability. Some people don't even want to hear sustainability. When you say sustainability, some people become, they just think it's I don't know what it is. They don't even like to hear it. But it's something we need to really appreciate and know that it provides a competitive advantage for us. See all what is happening, bushfires everywhere. I saw a guy yesterday, in the train where, from Lismore, and immediately he said, I'm from Lismore. The next thing, hope you guys are doing well with all the floods and bushfires. I don't know if you know about Lismore. It's one small city up to north, yeah. Yeah, they've been having issues with floods. I think they have like 2 times floods and bushfires, and it's been a lot of issues. So if we don't want to really tackle the problems of environmental, sustainability, all these challenges we are having with fires, with all of those, if we don't do the little things, we're going to have these problems, and and the frequency and intensity will continue to increase if we don't do anything about it. So AI in manufacturing energy, it's just all that I've been talking about. There is need for us to monitor, like we do with our own products, equipment, monitoring, continuous monitoring in real time at asset level, across process lines, no blind spots. You can, really create real visibility, and you know what is happening. If there's any challenge, any anomaly, you know, you'll be able to really identify it very fast, and you deal with it. Then, of course, it also affords the opportunity of optimizing the process, you know, for better efficiency. And you also align energy to the demand. You just don't waste energy anyhow, you know. You're more specific. You know, it's what is needed that is supplied to reduce waste. So if all of this is done, like if, for example, someone decides to do business with us and say, oh, I'm installing the monitoring device, these are some of the benefits, you know, possible benefits. Based on our computation, you could reduce as much as 10 to 30% of the energy waste in the system. Or in other words, 10 to 30% energy savings. And in terms of the reduction of greenhouse gas emissions, up to 40,000 tons of CO2 equivalent per year, you know, and the payback period is short, within 3 to 9 months. And specifically, we are looking at the example of steel plants, which we say uses about 200 gigawatts hour of electricity per year. You can save as much as 60 gigawatt hour per year. That's a lot, you know. In terms of CO2 equivalent, you can save as much as 40,000 from the 140,000 tons of CO2 equivalent per year. That we, you know.
Not even 1% of a lot.
Yeah.
These power bills can be like billions of
dollars. Yeah. So just 1% is a lot of money.
Would it be accurate to reframe this as, you know, instead of looking at it from a monetary perspective, power bills, because they're probably, you know, there's profit. I don't think that's a concern for them, especially at this scale. Can we look at it as the raw material input, as you suggested earlier? Because in order to supply, say, 200 gigawatts of power, I don't know how many. I don't think they use sustainable power sources like solar. And if they do, then I don't think that's an issue.
No, even if they do, like, you know, even if it's solar, even your solar, you still want to, you know, make it efficient.
But why?
You still want to know what you are using for what.
If it's
because you know what do you say?
If it's renewable, why would you want to optimize it? So I've shifted from using fossil fuels, no longer burning coal to power this steel plant. Now I'm using solar. It's completely renewable. Yeah. I no longer need to monitor.
But even at that, you don't just want to waste it still, even if you are not, even if it's.
You can export DNA.
You can still monitor what you are using, and if it's in excess, you can give it to someone.
You do a larger export.
Yeah.
Right. I just see that as, you know,
it's true. Most people actually, it's one of the major things that questions. You know, people will just tell you, I'm already using solar. You know, and they just use that to wipe. But even if you are using solar, you can still monitor. You can still have an idea of what you are using. You know, even if it's just for reporting reasons, because you still have to report, even if you are using solar. You know, like all these things that I'm talking about, you still have to give your reports to the government. And you won't say, oh, because I'm using solar, I'm going to give the report.
You know? Do you think you can make a good replacement? Some people think they're using solar and they think they don't need to optimize their efficiency because they're using solar.
Yeah.
Do you think that would be a challenge?
Yeah, it is. Like I'm telling you, it is a challenge. Most people tell you that, oh, I've already switched to solar, so I don't think I need your product. But we tell them that they still need it, even if it's just for comparison. That, oh, when we're not using solar, this was it. Now that we're using solar, this is it.
I think the fault is the low export price. Because if you got such a low export price, people don't have the incentive to increase their export.
Well, the first thing that comes to mind is using that excess power. If you're monitoring it, even if you're on sustainable,
if you
monitor it and you find out hey, I have this much power that's being wasted because you're monitoring. That's the only way to find out.
Yes.
You can then think of a way to utilize that excess power,
Exactly.
which could be maybe,
Mm.
manufacturing something.
Mm. But if you don't, then you have. It's
Yeah.
always good to have that visibility.
It looks like it's an avenue for growth, right?
Whether it is.
Because it's expensive to set up monitoring systems.
I wouldn't say it's expensive for big organizations. It's not it's and the way we've structured it is, it's just that we have not really spoken about it. The way we structured it is such that we identify what the waste is, what, like, okay, this is how much you are wasting every month. This is how much it is in a year, this is how much the product will cost. And you might not even be the one to finance it. We'll get an organization to pay it for it. And it's from the savings that we make from you for each month that you pay back. So it's been structured. It's almost like free. It's not as if something, a big capital is coming from you to get this done. You get it? It's been structured so that it's very seamless, very easy to do. It's out of the waste, or the savings that we make for you, that you pay up for whatever cost.
I think one metric to look at is say if you're the toy manufacturer, you can assign like how many watts of energy per toy, and there could be like a variation, like a standard deviation. So like what you want would be like a predictable number of watts per toy that you're spending energy input, rather than this variable having like 100 a day, 300 other day, 200 a day. I think that could be one.
So it has a lot of application. You can use it to do a lot of things.
What about the accountant? What's your perspective on this? Dad's an accountant.
Oh, that's good.
I think every machine, we know that every machine uses the same amount of power to run. So if you are going to improve or to save some energies, I think you can't do anything on that, but the saving has to come from the waste. Maybe if there is any waste, by protecting that waste, you may save some amount of energy. Otherwise, is there any or if you don't make another improved machine that uses less power, and maybe you can get from that some savings amount.
So that's yeah.
How do you get the
Yeah, that's where we're going. The starting point is monitoring to create visibility. After you have been able to do that, then you now find ways of, the waste that you have seen in the system. How do you remove it? Like, apart from the normal monitoring, then you go to the management level. For example, let me give an example of maybe an hotel, and you've been able to monitor and you've been able to identify some waste in the system. So say in the morning for the kitchen, maybe before they start in the morning, maybe they start cooking. I'm just giving a practical example now. Maybe they start cooking at 10 o'clock, but you discover from your monitoring that they put on the oven or maybe at 8 o'clock. So you're able to tell, instead of putting it at 8, why not put it at 9:30? You're wasting this much of energy. That's one. So it's like what do we call it? Is it just looking at the timing of how they do things? That's one. Then two, like their refrigerators. There are special devices that we use, that we install in their refrigerators that help to reduce how much in terms of the energy consumption. I can't remember precisely how that process works, but it's very, very effective in reducing the cycle, maybe the compressor cycle or whatever. I don't know how it works, such that much energy is reduced. So we have for air conditioner too. We have for different things, different devices. Apart from the starting point is just the monitoring, but there are a lot of other ways of practically reducing energy usage, for organizations.
Right.
So but the monitoring is very important, because that's like the crux, is the starting point to really know if there is waste in the system, what's the waste in the system. Then later on you move on to the next level of dealing with the waste in the system.
Is any push by like the government to make companies like improve their energy efficiency?
I think the government is trying to. They are making effort, because, like I said, the truth of the matter is, the 2015 net zero emission targets will just be like a mirage if we don't really optimize efficiency. It won't work if we just say we are changing to renewables, we are changing to EVs, just like that. It won't work. The starting point should be, and the government also agreed, the starting point should be like efficiency first with what we have, then moving on to renewables.
Right.
So yeah, I think I've spoken about this. Yeah. So I've said it already in terms of the bottom line for manufacturing companies: immediate energy cost reduction within year 1 to 2, and of course optimize scheduling, which compounds savings because you have been able to optimize your schedulings. And the payback period is 3 to 9 months. About year 3, AI would have learned so much, and the performance will even be better. Predictive maintenance. What?
It's a very quick return.
Yeah, it is. It is. Most times, it is. That's from the and even in the real work that they are doing, that's how it's been.
But anything under 3 years,
Yeah.
that's
Yeah. So even if it's 1.5 years, it's still very good. 2 years, still very good. So like I've spoken to you guys. It's something that must be done, particularly now that the government is really focusing on, you reporting to us, you telling us about your scope 1, scope 2, scope 3 emissions, and energy efficiency must play a very significant role in all of this. So yeah.
Yeah. Cool.
Do you know if they do this for data centers? Big energy.
So it's only now that they're trying to segment different departments of AI.
I know the US, there's a big discussion.
That it won't be long before energy and AI come into the picture. But that being said, even while you were talking, I thought of a solution for your, say, someone is on being powered fully by sustainable energy, right? In terms of return on investment, there is capital that you have to put down to get solar. And from energy savings to break even, I think on average it's about 10 years, right? It's not an immediate return on investment.
Exactly.
But that being said, there's also, from the energy perspective, a certain amount of energy has gone into creating the solar panels.
Exactly.
Right, which has created emissions. And to make that return, you need to be able to do that by improving your current usage or efficiencies. Just like knowing, how much energy goes into manufacturing a toy, how much energy goes into manufacturing
solar. It's huge.
How long it takes to regenerate.
That's right.
It's huge.
So
Yeah,
that is something to think about.
And so about the regulatory pressure, I've spoken about it. So it's been tightened now. All over the world, including Australia with the ASRS that I just spoke about. So whether you like it or not now, you have to report your scope 1 and scope 2, and there is also, I think it's just a gap of 1 year when scope 3 is going to be mandatory again. But now it's scope 1, scope 2, but they give them like just 1 year that they have to find ways of estimating their scope 3. So all of this, and of course investors too, Many people, they are environmentally conscious. You know, they want to know what you are doing. What are you doing about the environment? Are you the type that says it doesn't really matter? You know, and you're making us go through the stress, like the guy from Lismore that I was talking to. You know, the stress they have gone through, having to deal with flood 2 times and fire once. You know, it's been so bad. And the frequency, interestingly, and the intensity of all of these, they are predicted to get worse. The fires, whether we like it or not, if we don't change the way we do things, the fires in frequency and intensity will be more, the flood in frequency and intensity will be more moving forward. And that's the reason why you have to do something, and we have to do something fast. You know, so the regulatory tightening will also make organizations that are not willing, you know, that are not making efforts to like change their ways of doing things and do something about it. So what happens if you hacked? I'm not talking to you as if I'm talking to people, you know, who are going to take up the, you know, sign a deal with us. So if you hacked, there will be lower production costs, of course, stronger ESG positioning. You'll be able to like use the data for operational control, you know, like all the real-time data that you will be gathering, you know, you can use it for that. You can even use it for other purposes. Regulatory readiness, I've mentioned it, you know, so these are all the things that I've mentioned before. But if you delay, look at what is going to happen, you know. High energy prices, you are not doing well for the environment, you know. You have to run up and down when it's time for you to report the regulatory with the regulatory policy in place. So it doesn't make any sense not to do something about it. So final notes. I'll just read it. Can you afford to keep losing 10 to 30% of your energy spent? Energy is no longer just a cost. It's a strategic lever for profitability and sustainability. The opportunity costs of inaction is too high. The technology exists, the data exists, the savings are measurable. The cost of inaction is infinite. The time to take action is now. Thanks.
We're on time. We're just a little bit off. Thank you,
many-
Dr. Olu.
How many minutes?
We're 8 minutes behind. You know, we've had to wait for some people. This is proving to be a good rehearsal. Now, I couldn't help but think that energy would be the new currency at some stage. It already is a currency. Yeah. Now, what I'm looking for, bear with me, just setting up the next workshop.
I think even if you have a data center even in the States, if you have an application, even though you're saying like solar energy in the States, you still can reduce the number of solar panels you need.
Yeah,
and they can
exactly.
invest the money
Somewhere else. Yeah. So, yeah, if you do the monitoring first, then you save some coins to invest somewhere else.
Maybe you should talk to Elon Musk and doing data center.
I think his batteries probably have the same kind of capability. Yeah, the Tesla batteries. Just the hotspot is taking a while. I did download a local copy, but
Yeah, Tesla's very good at monitoring things at that level.
Mm.
If I look up in my car, like there's like a service mode you go in,
Yeah.
and it'll give you all the wires, the whole diagram of all the connections. You can see if something's gone through.
guys,
Yeah. Yeah.
while I prepare the next slide, could everyone just? I found the QR code for the Turing test. So if you've got your phone, could you scan this? I just want to see if it's worthwhile.
What's running through them to get QR code?
Surely you should be able to scan it from a distance, no?
Oh, I didn't try. Because my phone's old. Can you believe this is like
Hell,
iPhone 10?
I've got iPhone 6.
It's still
Yeah, it still runs perfect.
Yours iPhone 6.
Just now though, because iOS 16 is required for most apps to run. It's getting to the point where,
So you're gonna change.
yeah, well,
Someone using an older phone.
yeah,
6. Like my old one was 6.
yeah, 6S, the little tiny one,
No, no.
just a normal 6. I mean, yeah, it scales and it remains. So, yeah, put your name in and
Now
But-
you just run things on the cloud. You don't need a strong CPU or anything. That's why Intel's on that
because of it.
CPU.
All right. For anyone watching a recording of this, sorry for making you wait. Is it, I've just got everyone to do the Turing test. It should only take about a minute, so I'm not sure if the chat's been finished. Basically, after a minute, they have to guess if they were talking to someone else in the room or if they were talking to an AI. So. You got it wrong?
Yeah, I guess it was human.
It was a bot? Yeah.
Yeah, I got it wrong. Say human.
You said human as well?
Because they didn't have like capital letters at the start.
Oh, yeah. Did it say good day?
Yeah, like good day, mate.
Yeah. I mean, who in this room is going to say good day, mate, though, right? It's the biggest giveaway. Yeah. So something that's attached to the Melbourne AI Hub members area. Something we slapped together. Obviously, better builds, collaborated builds work a lot more. They're a lot more polished than individual builds, and I've been building individually. And one of the hopes is by the end of the remaining 2 workshops, I will stop building actually, and I'll just have Stefan and Ola start building or refining what's already there. That being said, in order for them to do that, they need to understand what's under the hood. What are we really working for, or what are we working with? And so this session is the concluding session for workshop 1. We'll just go through exactly how AI works. Now, acronyms, very interesting. These acronyms, just to throw some statistics out there, they say that between the ages of 18 to 34, there's about 70% of people in Australia use AI. But that's at least once every 12 months. So its adoption is quick relative to other technologies because it's so accessible. It's just on your phone, you go to a website. But at the same time, there are acronyms associated with it that you will eventually have to, or you will be curious enough to understand. So LLM, large language model. Maybe we can all say this together. NLP, natural language processing. RNN, recurrent neural network. LSTM, long short-term memory. And you've got bi-LSTM, which is just bi-directional long short-term memory. BERT, that doesn't come out as often as it should, but bi-directional encoder representations from transformers. GPT, everyone's saying ChatGPT. No one knows what GPT stands for. Basically, it's generative pre-trained transformer. And ANN, which is artificial neural network, right? So just some acronyms to get our headspace in the right sphere. So in the 1980s, when there were two guys, one by the name of Warren McCulloch and the other by the name of Walter Pitts, they introduced the idea of artificial neural networks, or ANNs. And this was back in the 1940s. And it was then known as nerve nets. So it had a different name. Of course, 1956, as we mentioned earlier, is when we started using the name AI, or artificial intelligence. Progress stopped until the 1980s, when Geoffrey Hinton and his group came up with this breakthrough in backpropagation. Basically, the easiest way to explain it, algorithms became multi-layer. And historically, there was opposing camps to AI. There was symbolic and connectionist. So the connectionists, or the machine learning, was also divided into two schools of thought, which was either shallow or deep. So shallow meaning you needed a human in the loop to feed the neural networks information, whereas deep could feed itself. And that just sets the stage. Sorry, just having a little trouble switching through slides and going through notes. But the bridge between learning and modern LLMs became a shifting philosophy of computation. So the idea that a philosopher by the name of Ludwig Wittgenstein argued was that a word, the way you use it is its meaning. So the way you use a word is its meaning. And this was called the distribution hypothesis. And alongside it, there was another linguist who basically said that you know a word by the company it keeps. So, for example, if we use the word swimming, someone asks how you're going, and an Aussie expression is, I'm going swimmingly. That doesn't mean that you're going swimming. That means you're going well. But in the same phrase, if someone asks how you're going and you say, I'm going swimming, it means you're going swimming. It doesn't mean you're going well. So the word hasn't changed. The word swimming hasn't changed. But its meaning has changed because of the company that it keeps. So this was a philosophy that linguists put forward, The word shall be known by the company it keeps. Currently, we feed LLMs, or large language model words, which are typed. You type them into the computer, and then it kind of does some prediction to find essentially what the next word should be. That's right. So so just to break it down, when you feed words into the computer or you type them, the computer does not understand the words. What it does is it tokenizes the word. You will hear the word token come up more and more often as AI gets adopted. But essentially, tokens are numbers that are linked to either words, parts of words, or even individual characters. And so when you have tokenization, those tokens are given a number. So if you have the word and it can, or the example that I'd written here, Melbourne AI Hub is growing, for example, right? So when you put that into the LLM, it tokenizes it. It says Melbourne is one word, one token, AI is one token, Hub is another token. So it tokenizes per word, but it doesn't have to be per word. It can be per character, or it can be groups of words. And then it gives each token a number. So Melbourne becomes 104. AI becomes 27.
About 0.7 tokens per word on average.
0.7 tokens per word?
Something.
Yeah.
And then every language is different. So apparently Polish is the most AI efficient or token efficient language in the world.
I did hear that come up on the news.
It's very structured and it's very information dense in its words.
Yeah.
Interesting.
It is. So, we can go biblical, and the book of John starts in the beginning was the word, right? We can definitely take this to a different level. But just to understand how the computer thinks about it, once each the prompt is tokenized and each token given a number, each tokenized number is given a vector. So the way I like to think about it, it's like a space. I occupy a particular space in the 3 dimensions, and relative to me, all is different in one axis, about 4 meters. And same with Tech and Stefan. You're all occupying different spaces. So in the computer world, it's not 3-dimensional, and each tokenized or each token that's numbered can have, once it's vectorized, it doesn't have just 3 dimensions that it can occupy. It can have hundreds or thousands of dimensions. Well, I don't think there are any tokens that have trillion vectors.
You don't run any particular trillion. You just use a subset of that trillion.
Well, if you look at all the vectors, yeah, 100%. But per token, just to classify where it sits in the sphere of the model, its dimension, it's where it is determined by dimensions, and in the computer world, it's not 3-dimensional like in our world. It can have up to 1,000 or 100,000 dimensions, which means that all the other words that are close to it, so there can only be so many people close to me, right? I'm in 3 dimensions, but think about 100 dimensions. I can have a lot more people closer to me. So it gets vectorized, and that's what you call a neural network, or the embedding space. Now you guys would have seen embedding. Maybe you would have seen embedding with Gemma 4 or with Hermes.
I didn't know what that. I didn't look at the meaning of embedding.
So a model does not store data in the way that you think. Once something is vectorized, it's embedded into this space, so it can.
I I just call that excellent.
Yeah. It
That's very informal.
so it doesn't memorize every answer to every question. It just uses its embedded space to answer the prompts that you give it. So it can have, almost infinite iterations, because the space, if you change one variable in your prompt, you've moved to a different embedding space, which has different lots of dimensions and words close to them. So the embedding space is the model, essentially, and it has weights that it leverages. Going a little bit off the script, but words were no longer isolated symbols, rather they're neural networks, and mapping them onto dense real-numbered vectors with similar concepts, like beer and wine get grouped together. So with weights, the meaning emerges from the relationships between tokens. So weights are learned settings inside the model that get adjusted during training. So when you're training a model, you're adjusting these weights, and they draw parallel between what humans do and what AI does. So when we practice something, AI is trained, and training means you feed it lots and lots and lots of information, and then you remove something and see if it can predict what the response should be. And if it's wrong, you train it some more until it gets the response right. We have memory and patterns. They have weights, like I mentioned earlier. Attention is something I'm still not fully I haven't grasped, but we pay attention to context. You're at Melbourne AI Hub doing workshop 1. The AI pays attention to a particular word, gives it attention, and it kind of dictates the context. So attention moves between words depending on the weights.
It's got expert layer. So inside it, it's got like a maths like a layer, and then it's got like a biology layer or like a legal layer. I think you can call it expert. So it has like patterns of linking the vectors.
Yeah, I mean, if we're talking about it when we're visualizing the embedding space, it could have multiple embedding spaces, if that's what you mean by experts.
Yeah. That can help it to get the right context.
Still learning.
It's pretty complicated. Like the more I read, the more complicated.
Is it?
Yeah.
Is it because of the embedding space that, for example, you give a prompt, and at the end of the day, you might have different, outcomes for the same prompt?
So why, even if you give the same prompt, you get different outcomes?
Sometimes not completely different outcomes, but not exactly the same in terms of the outcome, the first outcome and the second outcome. You could still see some differences.
So generative AI, basically, it looks like it's generating something new.
Okay.
That works because the AI works with patterns and prediction.
Okay.
So it's predicting, and it never predicts. With prediction, you could even. So when I was doing isolating proteins and crystallizing proteins, the lecturers there took it to a whole different level and said that to get a perfect crystal, you have to consider where we are in terms of constellations. Like astronomy comes into the picture, because you're dealing with fundamental physical laws, and there are neutrons and all these things happening that we're not observing. So I feel it's probably the same case, because you're talking about electron movement, and that's probably affected by things that we don't fully understand. So it's definitely a field where it's a new field, and they're making discoveries every day. And sometimes it even hallucinates or makes up things. It gives you, very confident looking answers, but it could be completely wrong. And that hallucination has gone down since GPT-3. GPT-3 should just make up stories. But now I think they're at like 99% confidence that it's... Move on to computer vision.
Difficult to build a computer vision system. Well, an image is made of pixels. When we look at a picture, what we see are shapes and objects that we immediately recognize. However, what a machine gets is a collection of numbers, where each pixel is represented just by a single number, and we want to build a system that will tell us whether there is a car or not in that image. So the first thing that we need to do is to collect training data, and we will need some images that contain samples of cars, so that the machine can learn all the different ways in which a car might look. And then we also need examples of images without cars. Once we have built this dataset, the final thing that we need is the learning model. Neural networks are the way in which we build those systems. They are composed of very simple units that are interconnected with adjustable weights. And we will use all those images to set up the strength of the connections between the units so that the neural network learns to solve the task that we can.
For more MIT moments from MIT Open Learning, like, subscribe, or follow.
Remember, that was the first AI lab that was established in 1956, the MIT AI lab. So, how computer vision works. So, that short kind of summarized it well, but we'll go through it in a little bit more detail. So you have an image. When you see an image, the image you're looking at right now on the screen, it's actually a group of pixels. And those pixels are essentially code. Each pixel is determined by RGB, red, green, blue. And when you give different values to red, green, and blue, you can get all sorts of colors from the spectrum. I think you can get all colors just with the three variables. Here's a better slide to demonstrate that. For example, to get the color orange, you need to have particular values for red, green, and blue in each pixel. So red at 255, green at 180, and blue at 40. So 255 is the max value that the code uses. And then you can have, because pixels are grouped together, different values determine different colors for each pixel. Now, what the computer sees is the code. So you can see pixel 255, 180, 40. What we see is orange. Every image, you can see that just from this little snippet from an image, there's just lots and lots of pixels, which means lots and lots of code. The computer is not actually seeing the image. It's seeing the code that's responsible for showing us that image. Hence why they call it computer vision.
It's very interesting how they compress pictures as well. Because you can compress pictures down to a point where the human eye doesn't pick up any noticeable differences.
We're just about to see how the computer does that, actually. So AI vision or computer vision, it does it in three steps. The first thing it does is it classifies the image that you're looking at. It asks what is in the image. And again, that's because it's been trained through lots and lots of images, and it's able to compare the code and align it to this word within a neural network. So it's not seeing the way we see. Then it detects where it is in the image. So right corner there is a blue ball. And then it goes further into segmenting which pixels are actually part of that blue ball. That's all using the weights adjusted because of the training that it's had. A really good use case for computer vision is this thing that I found here. Basically, it uses the camera